Okay, so this is Taylor's series. Honestly, this is kind of like a day 2. Come on. That's why. This is a day 2, especially in my classroom, of Taylor's series, where we kind of have the fundamentals. So if you're not in my class and you're looking for it, look up basically day 1 of this on my YouTube channel. So yesterday we talked about, or in the other video, we talked about if our Taylor series was centered at 0. Now this is if it's centered at A. All you're doing is shifting something left or right. That's all you're doing in this. So notice how it has the same derivative, but we're evaluating it at the point where we are shifting it to. That's all we're really doing for this. Okay? Okay, so this example. And again, this is a continuation of a previous video, but that video was getting kind of long, so I cut it up into day 2. So suppose I have a derivative of all orders at 1. Suppose that the following values apply. Write a 4th degree polynomial, so I have my 4th, and use that to approximate f of 1.1. Okay, so I have my Taylor polynomial of 4th degree. Okay, so I start with my first one, 3, plus 4 over 1 x minus 1. Don't forget about this x minus 1. That is a very common mistake that, not gonna lie, I keep making. Minus 8 over 2 factorial, because I'm looking at my second power now. Minus 7 over 3 factorial, because I'm looking at my third term, plus 7 over 4 factorial, not term number I should say, but x to the x minus 1 to the 4th power. And now I'm going to use this to approximate 1.1. So all I have to do is plug in 1.1. So 3 plus 4 times 0.1 plus 8. I'm sorry, that's not a plus there. That is a great big old minus sign. 2 minus 1.1 squared minus 7 over 3 factorial times by 0.1 to the third plus 7 over 4 factorial 0.1 to the 4th. And then, honestly, this is just plugging in your calculator. And according to my notes, I have 3.3589. Okay, this example. Writing our 4th degree Taylor polynomial to approximate y equals cosine of x centered at x equals pi over 4. So I have my function is cosine of x. I have my function evaluated at pi over 4 is equal to root 2 over 2. You don't have to rationalize, at least in my class. So if you aren't rationalizing your denominator, that's okay with me. 4th degree, so I have to go up to my 4th derivative. Cosine, derivative of cosine is negative sine. I didn't forget my negative. F double prime of x is equal to negative cosine x. F double prime of pi over 4 is equal to a negative root 2 over 2. My third derivative, negative cosine of x is derivative of negative sine of x. Sine of x is root 2 over 2. I don't know why. I got distracted. You know what I'm thinking about? I'm thinking about the fact that I have no room left over. So my fourth derivative is cosine of x. Oh, isn't that nice how it kind of goes back? I think that's kind of fun. Okay, I'm going to look at my notes real quick just to make sure I have the right values. I do. Okay, so now our Taylor approximation of this. And I'm going to run out of space. That's what I was thinking about. I start with my first one, root 2 over 2. Then I start with my first derivative, negative root 2 over 2 over 1 factorial, x minus pi over 4. Again, don't forget that. I often forget that. I'm not going to lie. So then the next one, I go to my second derivative, which is also negative root 2 over 2, all over 2 factorial. I don't care, leave it like that. Squared. I've run out of room, so I'm going to carry everything down for my next one. So my next one is positive, so that's a plus a root 2 over 2 to the 3 factorial. Technically, that could go on the bottom there. Of x minus pi over 4 to the third plus a root 2 over 2 all divided by 4 factorial. Oh, I'm going to run out of room again. X minus pi over 4 all to the 4th power. And that's our Taylor, 4th degree Taylor approximation. Make sure I have that right. I do. I didn't forget any of my x minus whatevers. Now this is, actually no, I'm going to stop the video there.